Hi Year 12 Maths General students. This lesson is from Unit 3 of the Queensland Maths General syllabus, and we're looking at using Excel to deseasonalize time series data. The lesson objectives today are defining and calculating seasonal indices. We're going to look at smoothing time series data that features seasonality. Then we're going to plot raw and deseasonalized time series data onto Excel graphs so you can compare the difference. And lastly, fit least square regression lines to deseasonalized time series data. And we're going to use those models to forecast future values. So previously we've looked at mean smoothing time series data, and this deseasonalizing is specifically to smooth out seasonal or cyclic patterns. And this again helps make any apparent trends really clear. And when we develop models, long-term trends can be more effectively predictive. This whole deseasonalizing process involves finding what we call seasonal indices for each seasonal time period identified. They might be quarters, months, or weeks. To get the seasonal index, we need to firstly identify the length of the season. Secondly, we need to determine the seasonal average for one season, and also how many seasons are present in the data that we're looking at. We're just going to look at a graph that I used in a previous lesson. When we look at this graph, we can see that there are 3 seasons present. So the pink, the light blue, and the purple over a period of 12 months. And if we look closely at the recurring pattern, we can see that the one up and down season is 4 months long. So looking at that first pink season, you should be able to see that these 4 values make up that season before the next season begins. To get the seasonal average, we simply add up the seasonal values. So we'll add up these 4 values, and then we divide it by how many little time periods there are within that season. So there's 4 within this season. So for that example of the pink season, we add up the values divided by 4, and that gives us a seasonal average of 205.5. So you have to note that if there's multiple seasons present within your data, like we see in this example, the seasonal average for each season must be calculated separately. So the seasonal average value for the blue season and for the purple season will have different values to the pink season. Seasonal indices have a seasonal average of 1, and this is used to tell us how a particular value compares to the seasonal average, and that can be expressed as a percentage. Because your seasonal average is out of 1, any value above 1 is higher than the seasonal average. Any value below 1 is lower than the seasonal average. To get the individual seasonal indices, we take the actual value for the season and divide it by the seasonal average. So if we look at the graph produced earlier, we can see if we take month 1, its value is lower than the seasonal average. So I take its value of 200, I divide it by 205, and I get 0.97. If I take the 3rd month, it has a value of 210. So if I compare that to the seasonal average of 205.5, it's above that. So if I take the 210 divided by 205.5, I get a seasonal index for month 3 of 1.02. For that first season present, in the pink, these are the individual seasonal indices for each of the months. So you can see that month 1 and month 4 are below the seasonal average, and months 2 and 3 are above. When I've calculated the seasonal indices within the season, what I need to do after that is check the sum of the seasonal indices. And this will add up to the number of time values in one season. So if the season includes 12 months, the sum of the seasonal indices will be 12. If the season's a week, the sum of the seasonal indices will be 7. If the season's quarterly, the sum will be 4. In this case, one season is 4 months long. So when I add up the seasonal indices, thankfully they add to 4. Once we have our seasonal indices, we can then use them to deseasonalize the data. We can also use seasonal indices to re-seasonalize or put back in the seasonal aspect of time series data. And you can see that from the original data in yellow there, once I deseasonalize it and plot those deseasonalized values, you can see visually the smoothing effect that it has on the data. You can also observe when I look at the R-squared value of the actual data compared to the deseasonalized data, you can see that with the raw actual data, we only have a 30% correlation of data points to the trend line developed, whereas an 88% correlation of data points with the smooth deseasonalized data. So a bit later on, we'll look at how we can then use those models to predict future values. Looking at how we calculate the deseasonalized figures, to do that, we need to use the actual value, so from the raw data, and divide it by the average seasonal index. And that will smooth out the ups and downs you see in seasonal data. To calculate the average seasonal index, we simply take the sum of the seasonal indices for the same time period within all seasons and divide it by the number of seasons present. So for example, we saw in this graph here, there are 3 seasons. So we would find the seasonal indice, for example, for month 1, month 5, and month 9, find those seasonal indices separately and then average them to find the average seasonal index for the first month within a season. And we'll look at this process of averaging your seasonal indices further on. If we're asked to reverse the process and re-seasonalize the data, then we take the deseasonalized figure and multiply it by the average seasonal indice for that time period. And this will put back in the seasonal up and downs, which we find really useful when we make predictions for future value using trendline forecasting. When we're deseasonalizing data, I've just summarized a series of steps that we usually take when we're doing questions that involve deseasonalizing. The first step is always to calculate the seasonal indices if you need to. Sometimes you'll be given the seasonal indices in your simple familiar type questions. Secondly, make sure you average your sets of seasonal indices. Thirdly, you'll deseasonalize each data point. After that, with the more involved questions, you'll plot the raw against the deseasonalized values, and then from there we usually go on through to find the least squares regression line to develop a model, and then we can use that to make predictions about future values, which is called trendline forecasting. Ensure that any future values we've found, we remember to re-seasonalize them to reflect seasonality accuracy. Okay, so let's do some examples to clear this whole process up. So I'm going to start off with 3 simple familiar type examples. The first question is 2 of the quarterly average seasonal indices for ice cream sales at a popular canteen over time for summer is 1.35, and for winter is a seasonal indice of 0.73. Part A wants us to determine the percentage that the summer and winter sales are over or under the seasonal average sales per year. B wants us to find the canteen's actual summer sales. So we'll deseasonalize there. And part C, we're given the deseasonalized sales. So we're re-seasonalizing the sales for winter. Alright, so for part A, considering the value of the seasonal indices, summer is 1.35, so that's 135% compared to your seasonal average. If we interpret that, that's 35% more than what the average sales are for the year. Winter seasonal index is 0.73, so that means during winter we have 27% less than the average sales for the year. For part B, we want to deseasonalize the summer sales. So the summer sales total 16,345. Our seasonal indice for summer is 1.35. So if you remember from earlier, the deseasonalized value is the actual value divided by the seasonal indice for that particular period. So I'll simply divide the 16,345 by 1.35. So deseasonalized summer sales value will be $12,107.41. Lastly, for part C, I want to know the actual sales for winter. So I'll take that deseasonalized value of $12,005 and I'll multiply it by the seasonal indice for winter. So that gives me an actual sales value of $8,763.65. In this second example, we've got a fridge company predicting average sales of $160,000 for each quarter, and we're given the seasonal indices, and they want us to find the actual values of sales for each quarter. So this is where we're working backwards using that seasonal indice formula, and we're just going to rearrange it a little bit because the seasonal index for each quarter is going to be the actual value divided by the average seasonal value. So if we look at that first quarter figure, we've got a seasonal index of 85%, which is 0.85. So in order to find the actual, we simply need to multiply both sides by 160,000. Pop that in my calculator. I get $136,000 for that first quarter of actual sales. Press pause and see if you can quickly work out the other 3 quarters' actual sale values. Time to check in. How did you go? So second quarter, 203,200. Third quarter, 163,200, and fourth quarter, 137,600 in actual sales. For question 3, we've got a clothing store that's open 7 days a week and has the following seasonal indices. And you'll notice the index for Thursday is not recorded, and we have to calculate that missing seasonal index. So here we're just recalling that the sum of your seasonal indices will add up to be the number of time periods in your season. So here, because a season is 7 days long, that means the sum of the seasonal indices will add up to give 7. Okay, and instead of writing the sum of, you can use this little cool Greek symbol called capital sigma and say the sum of, it's like a weird E, the seasonal indices, and in this case is going to equal 7. Okay, so we need to find Thursdays. We'll simply just add up the other seasonal indices. We get 6.3 there. Okay, then using our fabulous solving equation skills, we'll minus the 6.3 from both sides. So Thursday is going to have a seasonal indice of 0.7. Okay, now we're going to move on to a more complicated example. In your class notes, you'll find a more thorough step-by-step guide when we do complex, familiar, or unfamiliar deseasonalizing questions. When you're presented with data, you'll be given a table, usually with multiple seasons within it. Your first job is to look at the data and identify how many time values there are in a season. So, for example, you might see there's 4 quarters to a season. That's a year long. They might be identified as summer, autumn, winter, spring. They might just be identified as quarters. From there, you need to calculate the seasonal average for each season. So if you can see, there's like 3 seasons within the table. For the first season, you'll add up the values you're given and you'll divide it by the time periods you're given per season. So if it's quarters, you'll divide the sum of the quarter values by the fact that there's 4 quarters. After you've done that, you'll then move on to calculating the seasonal index for each of your values in your table. And that's taking the actual value from the raw table and dividing it by the seasonal average you just calculated. And that will give you the seasonal indices for that particular season. As a check step, you should add up all of those individual seasonal indices. So, for example, if the example was looking at quarters, I'd add up the seasonal indices for summer, autumn, winter, and spring, and hopefully I would get 4. If it doesn't add to 4, you know that you've done something wrong. From there, usually because you've got multiple seasons, you need to calculate the average seasonal indice per time period. So that's where you'll take the sum of your time periods and divide it by the number of seasons. So for example, if I got 3 years worth of quarterly data, I'll take the seasonal indices for summer year 1, summer year 2, summer year 3, and divide it by the fact that there's 3 cycles. And that will give you your average summer seasonal indice. Now, from there, you're going to use those average seasonal indices to deseasonalize your data. That's where you'll take the actual data value and divide it by the average seasonal indice per whatever time period you've done. For example, for that first season, you take the actual summer data value and you divide it by the average seasonal indice for summer. Usually you'll be asked to graph the actual data as well as the deseasonalized data to visualize your smoothing effect. And we're going to use pivot charts on Excel to do that. From there, in most questions, you'll be asked to fit a least squares regression line, and that will give you a model or a trend line to use in that y equals bx plus a form, which you should then convert to your scenario context. Again, we're going to use Excel to fit that line. And then lastly, most cases you'll be asked to apply that model equation you've developed to make a prediction on a future value. And then lastly, whenever you've found your future response or explanatory value, make sure you re-seasonalize it. All right, so that's enough of talking about it. Let's actually do it so you can see how all this works. So question 4 here is a complex familiar question. We've got quarterly sales figures of number of houses sold by a real estate agent for each of the years from 2013 to 2015. So you can see, to start off with, you've got 3 seasons worth of data, and each of the seasons is broken up into quarters. So using Excel, we're going to determine the average seasonal index for each quarter, deseasonalize our time series data and plot it. From there, determine a least squares regression line to come up with a model. And we have to interpret what the slope means. And then lastly, we're going to use the deseasonalized data to predict actual sales for the 3rd quarter of 2017, which you can see is like 2 years into the future. Okay, so I'll get you to open up the Excel file and let's work through the problem. Okay, so you'll notice that I've organized the data vertically. This is important when it comes to plotting the data using pivot charts. All right, so let's work through the first part of the question, which wanted us to work out the quarterly averages of sales for each season. You can use your average command, which we've used on several occasions before. Okay, you simply select our first season's worth of data and it will work that out for you. So you can go ahead and do that for each of the 3 seasons that are present. Now that I've worked out the average quarterly sales per season, so for this first season it's 6, I'm then going to use that value to find the seasonal indices for each of those pieces of data. So for the first one, I simply take the actual and I divide it by the seasonal average. And to shortcut this, to carry it down, you put a $ in between the F and the 3 when it's looking up the average. What you can do is you can then use our friendly green square to carry down the formula, and you can see that it's always referencing that F3 cell with the quarterly average that we need to use in those. To the side, you can just do a quick check step. So that adds to 4, so we're good. So from there, we just continue to fill out the rest of the table. And I would check that my sums add up to 4. Yep. Yep, so good. Okay, so we're nearly to the deseasonalizing part, but for each quarter, I need to average the seasonal indices. So for example, if I'm doing the first quarter, so for example, for the first quarter, I need to average the first quarter of each of those 3 seasons. Then I'll go ahead and do it for the second quarter. So you hold down the control button to select cells that aren't next to each other. Okay, I'm just going to shift them to there. Before I move on to use those values to deseasonalize my sales data, I can't forget to do that last check to see that my average seasonal indices add to 4. Okay, and they don't. So I've done something wrong here. Let's have a look. To speed up the process, I've just color-coded the cells that all relate to the first quarter, second quarter, etc. And to check that it's selected the right cells in the formula, if I click on the formula bar, you can see that it highlights the cells that I've used. So if I check my first quarter, that looks good. My second quarter, they all look good. My third quarter, you can see here that I've accidentally selected a second quarter instead of the third quarter. So we can fix that up. Check it. Yep, it's now selecting. And you can see that my check over here, where I'm doing the sum, has now corrected to 4. So I've found my error. So now I'm ready to deseasonalize my figures. So to do that, I simply click my actual sales divided by my average seasonal indice for the first quarter. And what I can do is, again, I can pop in that $sign and I can copy that formula. So I'm using Control C and paste it in for every one of the first quarters that I have. And you can see when I check it, it's picking up D7, which is the sales data, and dividing it by that first quarter. Same for this one here, it's picking up the actual sales in D11 and dividing it by that seasonal indice for the first quarter. I'll then just go through and do that for the rest of them. Should do the check every time. Okay, so after I check through the data to make sure that they're all referencing the right cells, we'll notice that the deseasonalized sales have quite a few decimal places, and you need to think carefully about the type of data that you are analyzing. Because this is discrete numerical data, I need to round the answer to the nearest whole number sale. So to do that, I would right click, format cells, and get rid of those decimal places. So we've got counts of deseasonalized sales now. Just note though, if you have continuous data, so say you're measuring quantities over time, you would leave the deseasonalized data in decimal place form. Now it's time to plot the actual sales and the deseasonalized sales. Before I do that though, I need to tell Excel that each of these quarters belongs to each of those years, because when I create a pivot chart, it needs that information. So I'll select my relevant rows and columns, insert, pivot chart, put it onto a new worksheet, okay, and drag down the year and quarter to the axis category, and the sales and deseasonalized sales to the sum of values column. Don't want a column graph, so I'll change that straight away to a line with markers. Okay, that looks a bit better. And we'll go ahead and add our polished things like our title and our labeled axis. So lastly, we want to pop in the trend line for the deseasonalized data. So right click, add trend line, linear, put it onto the chart. Simply out of curiosity, I want to see the trend line for the actual data. I just want to do this so I can show you how much better the deseasonalized data trend points fit the trend line. So you can see the actual data has an R-squared value of roughly 4%. So that's a very weak correlation between the actual data points and the trend line that's being drawn. Compare that to the more smooth looking deseasonalized data points. You can see that the R-squared values increase to about 43.5%. So the correlation between data points and the trend line being created is a lot better. I mean, it's only moderate, but it's still a lot better than it was. Okay, let's go and answer these questions. I've just popped copies of what we've done on Excel back onto these lesson notes. So to answer A, determine the average seasonal index for each quarter. Well, that's where we worked out this column here. So the average seasonal indices are 0.72 for the first, 1.23 for the second, 1.44 for the third, and 0.61 for the fourth quarter. For part B, we deseasonalized our data in this column. The plot for both the raw data and deseasonalized data we've put just below. And so that's part B and part of C. So C, we want the least squares regression line, which we found by adding in our trend line. Rewriting the equation, you can see I've rounded it. So y equals 0.16x plus 5.5. So that means in terms of the response and explanatory variable, the deseasonalized sales that I make for each quarter, 0.16 times the quarter number plus 5.5. And when we interpret the slope, the 0.16 that we're seeing is essentially saying that we're seeing an increase of 0.16 sales per quarter. Lastly, we need to use our deseasonalized sale model to predict the actual sales for the third quarter of 2017. We need to rethink about the number of quarters that's gone past when I get to the third quarter of 2017. As I progress through the quarters that have been recorded, you can see by the fourth quarter of 2015, that's my 12th quarter. So I need to think about how many quarters more will pass until I get to the third quarter of 2017. So all of 2016 will be an extra 4 quarters, taking me to a total of 16 quarters. After that, I just consider that we're going 3 extra quarters into 2017. So that means a total of 19 quarters has gone by to get to the third quarter of 2017. If I go ahead and document this, I want to find the predicted sales for the third quarter of 2017. So I know this is my 19th quarter. To find my deseasonalized sales, I'll simply use the model. And I get a deseasonalized sales value of 8.54 sales. I then need to re-seasonalize that data by using the seasonal index that I've found for the third quarter, and then that puts back in the natural seasonality of the data, so I end up with my actual sales. Okay, so if I go and plug that in, I get a predicted sales value of 12.29 sales. I can't have 0.29 of sales, so I round that down to 12 sales predicted in the third quarter of 2017. So I would finish documenting that off. Alrighty, hopefully that's helped you all review how to deseasonalize your data using Excel, and that process, as you can see, gives us a reasonable model that we can use to make predictions for future values. Just making sure that we re-seasonalize any values that we find with the model to give a more realistic outcome. For those that need it and who can access it, I've popped some step-by-step instructions with screenshots showing you how to deseasonalize using Excel. So make sure you go over that process. And I hope that this has helped everybody understand how to deseasonalize data using seasonal indices, then to use the model and to re-seasonalize the model value to give us a good predictor on possible future values. Thanks, Year 12s.